Okay, here we have our last example, which is number 381 on page 469. A rectangular box without a top is made of 12 feet, 12 square feet of cardboard. Find the maximum volume of the box. So it's always best to try to draw these. Even if you're not good at drawing, you should at least attempt it. So here's a box, and it's empty. So I can see that side of it there. Okay, because it doesn't have a top on it. Okay, so let's say X is coming out of the board and Y is going over and Z is going up. So X measures the depth, Y kind of the width, and Z the height. In that case, volume is X times Y times Z, and that's the function I want to maximize. And then area of the box is the thing that is my constraint, because the area is there's going to be so the I can count there's this side, there's two of this kind, and there's two of this kind, and then there's the bottom. Okay, so the yellow sides are going to be X times Z. So there's two of those. And then there's two green sides. And there's only one bottom, there's no top. And that's equal to 12. So then my constraint function would be g of xy equals 2xz plus 2yz plus xy minus 12 equals 0. Okay, so then the gradient of v, that's going to be yzi plus xzj plus xyk, and the gradient of um, g is going to be 2z 2z plus y I plus 2z plus x j plus 2x plus 2y k. Okay, and then we also have the fact that so these are our three kind of equations basically, except we're saying really the gradient of v is lambda. But the really thing is like the gradient of v equals lambda times the gradient of g, which gives us really three equations. So let's write those equations down. So that means gradient of v equals lambda times v gradient g. So then yz equals lambda times 2z plus y. Y equals lambda times 2z plus y. And xz equals lambda times 2z plus x. And xy equals lambda times 2x plus 2y. And finally, 2xz plus 2yz plus xy minus 12 equals 0. So 2xz plus 2yz plus xy, and then I'll just say equals 12. That's a simpler way to write it. All right. So we have 4 equations, 4 unknowns. We don't care what lambda is. So the fact that I can solve for lambda in all 3 of these means that yz over 2z plus y equals xz over 2z plus x, and x, that's also equal to xy over 2x plus 2y. Okay. So I think the best thing to do might be to, of these, so really that, these 2 things now, so this equation and these 2 equations kind of give me all the information I need now. I was able to get rid of lambda. Now, what is going to be the easiest way to solve this? I think one way might be to kind of substitute for xz over here, perhaps. That could be one way. So if I could get rid of z's, yeah, maybe if I could get rid of z's, that would be good. So let's use some of these equations to get rid of z's. What's going to be the better way to do it? Let's use this equation to get rid of z's. So that means to get rid of z is to solve for z. So that means that x, so xz equals, so multiply both sides by the z denominator, equals 2z plus x times xy all over 2x plus 2y. Okay, well, let's subtract a z term back over. So xz equals, let's multiply together and then do that. So then 2z xy plus x squared y all over 2x plus 2y. And so then actually, I have a different idea. Let's instead attack, let me change directions here, and let's try attacking this one. I want to do that because I see that there's some symmetry, like the x's and y's are almost the same, which means I think I might be able to simplify that and down into an x equals y. So let's multiply those things by the common denominators. So yz times 2z plus x equals xz times 2z plus y. Okay, now if z is 0, then we have 0 volume. So that's not going to be our maximum. So z is going to be a non-zero number, which means we can divide by it. So then y times 2z plus x equals x times 2z plus y. Well, now let's distribute. So then I have 2yz plus xy equals 2xz plus xy. Let's subtract those from both sides. And so we're left with 2yz equals 2xz. Similarly, divide by 2z from both sides and I get y equals x. Well, that simplifies things a lot. So that means that if x and y are the same, then I now can write, I'm going to substitute for those things. Let's just do it only in x's. So then the things, my equation I still have going are that one, and then I'm going to, these basically, I use these, so now I'm going to use these. So now I'm down to two equations and just like a x and z. So let's rewrite them over here. So let's rewrite the g function. So x's and z and y's are the same. Let's just use x's. So 2xz and 2yz is just like 4xz, because x's and y's are the same, plus x and y is the same, so x squared equals 12. So we rewrite that one, and then rewrite the other one as x z over 2z plus x equals x squared over 4x. In other words, that's just x over 4. Because x can't be 0 because we're talking about volume. We can't have a 0 with thing. Okay, well, let's simplify that some more. Let's simplify that. Forget about this one. Just figure we've got two equations now. Let's rewrite those again. Just to, like, stay organized. It's always good to stay organized with your algebra. Plus x squared equals 12, and xz over 2z plus x equals x over 4. Okay, let's try to simplify that second equation, because fractions, these are my two equations that I have left to figure out. So let's simplify the second one, because denominators are annoying. So then multiplying by both denominators, I have 4xz equals x squared plus 2xz. Okay, now we're getting somewhere. So if I take, let's take these two now and move everything to have zeros on the other side. So 4xz plus x squared minus 12 equals 0, and 4xz minus x squared. Oh, but subtract the, so 2, subtract 2xz from both sides. So 2xz minus x squared equals 0. So I could add both of these to each other, or I could just get rid of z's. So if I take this equation and multiply both sides by, say, -2, then I get negative 4xz plus 2x squared equals 0. So then take these two and add them together, and I get the 4xz's cancel out, and I get 3x squared minus 12 equals 0. So then x squared is 4. So then x is 2 or is positive or -2, but we're measuring things. We can't have a negative measurement. So x is going to be positive 2. And if x is 2, then that means that y equals 2. And then if x is 2 and y is 2, then go back to whatever function we have that's simplest with z, maybe this one, and say, okay, well, x is 2, so then 8z plus 4 equals 12. So 8z equals 8z equals 8, and so z equals 1. And so then that means that our box is a 2 by 2 by 1. Let's double check that that works. So going back to our picture of a box, if we had a 2 by 2 by 1, then we have 4, and then on the base, and then each side is 2 and 2 and 2 and 2. making 8. So 4 and 8 is 12. And so yes, a box that's 2 by 2 by 1 will use 12 square feet, and it'll hold 4 cubic feet. So then our final answer is volume equals 4 feet cubed, which actually shows the answer in the back of the book said 2.0, and that is incorrect. So the book is not always right, which is a sad reality. But that is our last example from this section.